Hello class, welcome to this video on 7.3, test for parallelograms. So our essential question, I'm going to go ahead and write it down here, is how can you test and determine whether a quadrilateral is a parallelogram. Okay, so how do we test that? How do we test if I give you a quadrilateral if it is a parallelogram? So there are a few conditions for determining whether something is a parallelogram or not. The first thing is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Also, if both pairs of opposite angles are congruent, then it's a parallelogram. If the diagonals bisect each other, then it's a parallelogram. So there are a few tests, and here's another one. If one pair of opposite sides is both parallel and congruent, then the quadrilateral is a parallelogram. So essentially you have like 4 or 5 tests to do to determine whether something is a parallelogram or not. So number 1, really straightforward. Here opposite sides are congruent, so you can tell that it's a parallelogram because of theorem 7.9. Theorem 7.9 states if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Okay, so it takes care of example 1, really straightforward. All right, so example 2, we have something that we want it to be a parallelogram. And so if this is a parallelogram, if we want it to be a parallelogram, then we have to use the conditions. So one of the conditions was that if the opposite angles are congruent, then it's a parallelogram. Okay, so it says find the values so that the side of the eraser is a parallelogram. Okay, so if we want this to be a parallelogram, then the opposite sides have to be congruent, right? So which theorem will we use? So this theorem is theorem 7.10, right? So theorem 7.10, which states if both opposite angles are congruent, then the quadrilateral is a parallelogram. Okay, so then if we're going to set these equal, then 7x is equal to 56, right? And so we're going to divide by 7 on both sides. So we get x is equal to 8. And then for the second one, we're going to set these two equal to each other, right? If they're supposed to be equal, because if they're opposite sides. So let's solve that over here on the left side. Okay, so we need to subtract 4y on both sides and then add 26 to both sides. So this cancels. We get 30 is equal to y. So when x is equal to 8 and y is 30, then the quadrilateral becomes a parallelogram. All right, so here's the check. So again, just pause it real quick just to make sure you understand this. All right, so remember that this is a quadrilateral, has 4 sides, so the opposite sides have to be congruent for this to work, right? So we're going to set those congruent. and solve it. So we got 3x minus or plus 4 is equal to 5x minus 2. So we're going to solve this, subtract 3x on both sides, and then add 2 to both sides. We got 6 is equal to 2x divided by 2, and so x is equal to 3. All right, and then we're going to get y, so set the other two equal, so 4y minus 9 equals 2y plus 5. So subtract 2y on both sides, add 9 to both sides. We get 2y equals 14 divided by 2, so y equals 7. All right, so what we use is that if both opposite sides are congruent, then it's a parallelogram. The quadrilateral is a parallelogram. And if you recall, that was theorem 7.9. All right, so let's look at the last example for the lesson. Really quick lesson today for this one. So determine whether quadrilateral FGHJ is a parallelogram by using the midpoint formula. If it is a parallelogram, write a narrative proof. If not, justify your reasoning. Okay, so remember that in theorem 7.12, 11, the diagonals, if they bisect each other, then the quadrilateral is a parallelogram. So we're using theorem 7.11 here. Okay, so for if you have a parallelogram, well, the way you know that, well, if you have a quadrilateral, the way you know it's a parallelogram, or one of the ways, is that the diagonals cut each other in half, right? Well, if the diagonals cut each other in half, that means this point has to be the midpoint for both of them, for both diagonals. So if we can determine the midpoint using the midpoint formula, and if the midpoint is the same for both diagonals, then it must be a parallelogram, okay? So here we're using theorem 7.11. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Okay, all right, so step one, let's calculate the midpoints. So let's write down the coordinates. The coordinates for F are -2, 4, J is -2, -1. Coordinates of G are 4, 2, and H are 4, -2. Okay, so let's calculate the midpoint of GJ. So we're doing the midpoint for that, okay? So we got x1 plus x2 divided by 2, y1 plus y2 divided by 2. So add those x coordinates and add those y coordinates. So that's what we have here, okay? So your x1, x2, y1, y2. So 4 plus -2 is 2, right? And then 2 that's for this one right here. And then 2 divided by 2 is just 1. 2 plus -1 is 1, so it's just 1/2, right? So it's 1, 1/2. So 1 and 1/2. That's what this point represents. This point in red. Okay. Now we want to find the midpoint of FH as well, and we want to see if it crosses at the same point. All right, so we're going to do x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay, so here we got -2 plus 4 is 2, 2 divided by 2 is 1, and then 4 plus -2 is 2, 2 divided by 2 is 1. Okay. All right, so the coordinates of the midpoint are actually 1, 1. So right here, the point is actually right here. This is the midpoint. And you can see that the midpoints are not the same, right? This midpoint is 1, 1. This one is just below that. The midpoints are not the same. Therefore, these do not bisect each other. And therefore, it's not a parallelogram, okay? the diagonals, because the diagonals do not have the same midpoints, it's not a parallelogram. Okay. All right. So for the check, let's show you. You can test this using midpoints, but we're going to show you another way of doing this. We're going to use the distance formula. Okay. Remember that we have to prove that to use one way to prove that this is a parallelogram is by looking at the opposite sides. If the opposite sides are congruent, then it's a parallelogram, right? So let's go ahead and test that. You can test that using the distance formula, right? So recall that the distance formula is square root x2 minus x1 squared plus y2 minus y1 squared. All right, so the easy way is we can count. So we can just count this. So how much up and over? So it goes up 1, 2, 3 and over 2. And this one goes over down 3 over 2. And then notice that this here goes down 1 and over 1, 2, 3, 4, 5. And then same thing here, this goes down 1 and over 5. And so you can clearly see that this is 1, 5, 1, 5. So these are congruent. They have to have the same length. This is 2, 3, and 2, 3. So these have to be congruent. And therefore the opposite sides are congruent and it's a parallelogram. I'm going to show you the calculation for the distance formula, however. So to get AD, which we know is the same thing as BC. So use the distance formula, square root x2 minus x1 squared. So that's the 2. So it's 2 squared plus 3 squared. We got 2 squared plus 3 squared. Remember that the 2 is the is the difference between x2 minus x1. The 3 is the difference between y2 minus y1. Okay, and so we get square root of 2 times 2 is 4. 3 times 3 is 9, so it's a square root of 13. Okay. Now let's do the purple one, which is AB, and AB should be equal to DC or CD because they're both 5, 1, 5, 1. So square root the 5 squared plus the 1 squared. So we got square root of 26 plus 1 because 5 times 5 is 25, and 25 plus 1 is 26. So we can see AB is the same as CD, and this is the distance. AD is the same as BC, and this is the distance, okay? You don't have to calculate this in order to say that it's a parallelogram because we know the sides, but I do want you to practice using the distance formula just in case they asked you for the distance, okay? Because they could ask you that. If it's parallelogram, write a narrative proof. Okay, so here we can see that yes, use the distance formula to find both pairs of opposite sides are congruent. Okay, and again, if you used a method that we talked about up here, you would get the same answer. You would get the answer that it's a parallelogram, and I will quickly show you that down here. So if we did midpoints. So, for example, let's do the midpoint of AC. AC is, we got to do the midpoint of the diagonals. So midpoint of AC. All right, so the midpoint, the coordinates of A and C. The coordinates of A are 1, 2, 3, 1, 2, 3. So it's the coordinates of A are 3, 3. The coordinates of D are 1, 0. C is 1, 2, 3, 4, 5, negative 1. And B is 1, 2, 3, 4, 5, 6, 7, and 2. All right, so let's do AC. So 3 plus 5 divided by 2. 3 plus negative 1 divided by 2. All right, and then that's equal to 8 divided by 2 is 4. 2 divided by 2 is 1. Now let's do the midpoint of BD and see if they're the same. All right, so BD, 7 plus 1 divided by 2. And then 0 plus 2 divided by 2. And notice you get the same answer, 4, 1. These are equal, and therefore it's a parallelogram. Okay, so that's another way of doing it. This is the way we did it up here. But again, I showed you a different way originally. Okay? All right, that's going to do it for the video, guys. Hope you found this useful and informative, as usual. See you in the next one.